All right, we're going to do 7.4, part D. So let x of t be a signal with Nyquist rate omega sub naught, and we want to determine the Nyquist rate for D, which is x of t times cosine omega sub naught of t. Now, the information we're given in this problem is that x of t has a Nyquist rate omega sub naught, right? If x of t has a Nyquist rate, then that tells us that x of t is periodic. And it also tells us that if x of t has a Nyquist rate, then x of t has a maximum frequency constant, and we'll call that omega sub m. Now, this note from page 519 in the textbook, the frequency 2 times omega sub m, which is 2 times the maximum frequency constant, under the sampling theorem, that is commonly referred to as the Nyquist rate. So right, we have a relationship then. We have 2 omega m is equal to the Nyquist rate. And here is our Nyquist rate, omega sub naught. Okay, so, and we, of course, we could rewrite it that omega sub m is equal to omega sub naught over 2. Now, x of t times cosine of omega sub naught of t. Now, we know x of t is periodic. We know because it has a Nyquist rate. We also know it has a maximum frequency constant. So let's just solve this a different way than Dr. Wang did in the practice problems. Let's make an assumption. Let's assume x of t is equal to the real part of e to the j omega sub m of t. Okay, so we're just and that would just look like this. This is just a cosine omega sub m of t, right? We know it's periodic, so we can just say we can make a simple assumption it's a cosine, and we know it has a maximum frequency constant omega sub m. All right, and we can represent it like this. Now, we could also represent the cosine of omega sub naught of t just by taking the real part. So let's do that. We have x of t cosine omega sub naught of t, and that's equal to, and we'll replace x of t, that's the real part of e to the j omega m of t, and that's times the real part of e to the j omega sub naught of t, because the real part of e to the j omega sub naught of t is equal to cosine of omega sub naught of t. And taking the real or imaginary part is a linear operation, so we can factor that out, and we get that the real part, we get that x of t times cosine omega sub naught of t is equal to j t. Well, here I'll write it out step by step. We get j omega sub m of t times e to the j omega sub naught of t, and that's equal to the real part, and we're just going to combine those. We get j times t, and we get omega sub m plus omega sub naught. Now, omega sub m plus omega sub naught, here's our relationship for omega sub m right here. So we get omega sub naught over 2 plus omega sub naught, and that's equal to 3 omega naught over 2. So this whole thing right here becomes e to the j 3 over 2 omega sub naught times t. And that is x of t times cosine omega t. So let's, almost done here. We'll just write this out one more time for clarity. That's equal to the real part of e to the j 3 over 2 omega sub naught of t. And that's going to look like this. That's the real part of cosine 3 over 2 omega sub naught of t plus j sine 3 over 2 omega sub naught of t. Now, the sinusoid, the sine function is being multiplied by j, which is in the imaginary number. And here's our real part, the cosine, right? So our final statement, using our assumption that, using this assumption right here, which is perfectly fine, is that x of t times omega sub naught, x of t times cosine of omega sub naught of t is equal to cosine of 3 over 2 omega sub naught of t. All right, then that means that x of t cosine omega sub naught of t has a maximum frequency content of 3 over 2 omega sub naught. All right. And if we want to know the Nyquist rate, the Nyquist rate is 2 omega sub m. Well, that's equal to 2 times 3 over 2 omega sub naught. And that's equal to 3 omega sub naught. And here is your Nyquist rate. So that's another way to solve that problem. The tricky part is you just need to know what the definition of the Nyquist rate is. And here's another term called the Nyquist frequency. Now, the Nyquist frequency is also called the maximum frequency content of the signal, but as long as you know the definition of the word Nyquist rate and its relationship to the maximum frequency content of the signal, you should be all right. Thank you.